Welcome, everyone. My name is Angad Singh, and one of the PMs at Sumo. You're probably familiar with the troubleshooting production issues today and might be aware of the challenges involved in the process. In this session, we are going to talk about a new feature that we are excited to launch at Illuminate called Alert Response that tries to address some of these challenges. Before we begin, a little bit about myself. I am a new dad. My son was born just before COVID, and he keeps me and my wife busy. So most of the time goes into that. And whenever we are not attending to him, I'm also a full-time PM at Sumo, right? And I manage the observability experience, the alerting, as well as the dashboard teams within Sumo. Prior to that, I also was involved with the log search and the data tiering aspects within Sumo. Before Sumo, I was actually an engineering lead at Fiserv and spent around 6 years with that organization. So for today's agenda, we are going to cover a couple of things. Firstly, we'll look at some of the pain point associated with troubleshooting production issues. Then we'll go look at the alert response feature and see how it solves some of these pain points. And finally, we will do a demo of the functionality and subsequently wrap up the sessions with some Q&As. So what is this? What are the steps in a troubleshooting process? The way we look at it today, there are 3 basic steps that any on-call engineer will follow to troubleshoot issues in production. It starts with the monitor step, where they will get notified about an issue. This is essentially the what. Then you move on to the diagnose step, where the on-call will try to identify components that are involved with this issue. This is the where. And finally, you get into the troubleshooting stage, in which case you're trying to isolate the root cause to a specific components out of all the components that you've identified. This is the why or the how, essentially. Today, monitoring is an automated step. A lot of observability tools are out there that help you do that in an automated fashion. But the diagnose and troubleshooting steps are unguided and non-automated today. These are also the steps that take the most amount of time during an actual production issue. Let's dig deeper to understand these steps a little bit better. Let's start with the first step, the monitor step. As mentioned earlier, this is when the on-call receives an alert. And he will typically have a few questions on his mind, right? He would want to know what has happened and how big is the impact. He would also like to know whether the issue is a false positive or false negative, because his troubleshooting steps will be guided by those questions. And to help answer these questions, he would typically try and gather information from the alert itself. But the information in the alert is typically restricted to the KPI being alerted. In the screenshot here, you can see a latency alert, which can tell you a lot about the latency, like when it started, how long this issue has been going, but it does not answer all of the questions that I mentioned above. Therefore, the user will typically look at other sources to get this additional information, right? And the biggest pain point, therefore, for him is the lack of additional contextual information that can help him validate the magnitude and severity of the issue and get started with the troubleshooting process. So next step is the diagnose stage. Once he has reviewed all the information and decided to act on an alert, he moves to this step, right? Here, the on-call wants to gather additional contextual information about what else is happening in the system that might help him get to the bottom of the problem quickly. At this stage, he'll probably have 2 things at the top of his mind. A, what else is happening in the system that might help explain the issue, like I mentioned earlier. And B, where should he look to get that information, right? And he will typically try and answer these questions by reviewing application infrastructure KPIs manually to find abnormal behavior that can be correlated to the issue. Now, this information typically resides across multiple best of the breed tools like Sumo Logic, New Relic, Datadog, etc., whatever tools you're using to get your end observability. And then the on-call has to know A, how to use these tools, how to navigate across these tools, and B, he also needs to know where exactly within these tools he can find the relevant information he's looking for. Right? And once he's gotten that information, he can start to collate this information and form hypotheses. Now, the biggest pain point at this stage is A, somebody needs to create these service or infrastructure level KPI dashboards for him to review. He also needs to know how to use various observability tools like Sumo, New Relic, Datadog. And if that was not enough, he also needs to know how his team or his company organizes information within those tools. And eventually, because of all of this manual process of creating and finding information, this creates two information silos. Now, once the on-call is done with gathered all the information and formed all the hypotheses about the potential root cause, he moves on to the third and final step, which is the troubleshooting. Right? Here, he will review the information he has gathered so far and dig deeper to validate his hypotheses to find the underlying problem. Right? The top of the mind things here are probably, are the observed symptoms that he found during the monitor and diagnose stage relevant to the root cause? And B, has this type of issue happened before? And are the observed symptoms similar to the earlier issues that happened in the past? Right? And he will typically rely on his system architecture knowledge and muscle memory developed from past troubleshooting experiences to connect the dots between the various anomalies happening in the system, right? To try and find the underlying issues, right? He would also need to have in-depth experience in using various tools like Sumo to perform ad hoc analysis to get supporting information around his hypotheses, right? Both of these things are hard to do. Intuition and muscle memory take a long time to develop, and typically new joiners therefore will have a tough time being on call. And secondly, not everybody is proficient in doing ad hoc querying, right? Because it requires technical know-how of the query syntax, which takes, again, time to develop, right? So in a nutshell, we have three major categories of pain points in the entire troubleshooting experience. A, you need to know your system intimately in order to troubleshoot well. B, you also need to know how to use observability tools and be well versed in your organization's way of managing content within these tools. And lastly, you need to be proficient in manual correlation and to connect the dots between the various observations. Now, all of this means that you need to be an SME. And if not, then you're out of luck and troubleshooting might take a long time within your organization, right? So let's see how we solve this problem. So this is where the alert response capability comes into play, right? It tries to address this problem by providing curated out-of-the-box experience to help guide on-calls to troubleshoot issues quickly. And it does that by A, surfacing relevant information about the alert, like what triggered it, how severe it is, or is it an isolated or a systemic issue? And B, it also helps guide the root cause analysis by automatically identifying abnormalities in the system related to the alert using machine learning analytics. All of this happens out of the box when you set up alerts within Sumo Logic, and there's no additional step required. So let's dive a little bit deeper to see what alert response does. We try to provide two main types of information on this alert page, the new alert page that we have created. The first one is, we call it alert details. Here we give basic information about the alert, like what triggered it, a visualization to show the trend of the alerting KPI over time. We also show related alerts firing in the system and the history of how this alert has performed in the past, right? And finally, we also show some custom playbooks that an admin might have configured on the alert. These playbooks can contain tribal knowledge that an on-call should review, right? All of this information is essentially given to help the user understand the issue better and to start the troubleshooting process much more quickly. Next, we also provide alert context. This is system curated insights that might help the on-call to get to root cause more quickly. These insights are presented in form of cards to make it easier for the users to consume. Let's review them in a little bit more detail. Right? The first card is called log fluctuation. It identifies changes in log patterns that might help explain the underlying issue. Right? It will, for example, find patterns like error, exception, timeout, etc. Right? Here, for example, this card is telling us that there are some failures happening trying to get product recommendations. And these failures all started happening after the alert. We have 64 log messages that contained this product recommendation error after the alert happened compared to 0 before the alert. The next card is dimensional explanation. Here, the system analyzes log data and surfaces dimension or key value pairs that might help explain the alerting condition. Here, for example, this card is telling us that errors started happening while talking to the cart service, right? The last two rows here sort of point towards that. And it is also telling us that these errors trying to talk to cart service were present in 80% of all the messages after the alert happened. So definitely gives you a smoking gun here. The next card is called Anomalies card. In this card, the system tries to find anomalies in your metrics data reported by various entities over time, right? In this example, we can see a bunch of anomalies that the system has identified on the front-end service, the currency service, and the cart service, where there seems to be some pod failures happening, right? And it is surfacing all of these anomalies in this sort of a timeline view to make it easy for you to consume this information and act on it. The last card is the benchmark card. This surfaces abnormalities in the data reported by various entities compared with other Sumo cohorts. So we are essentially comparing your data with data from other Sumo customers and surfacing abnormalities, right? This card, for example, is telling you that service unavailable while creating an instance, you saw this type of error 32 times more than the rest of Sumo cohort. Now that you are familiar with how alert response feature works, let's look at a demo. In this demo, we are going to simulate a real outage on an online boutique store where users can shop for various products. We are simulating the outage by increasing the load on the application and failing one of the services behind the scenes. In this case, the service is failing because it is unable to scale up properly. Now let's see how alert response helps us get to the root cause of the issue quickly. Hello, everyone. In this demo, we'll see how alert response helps troubleshoot issues quickly. The notifications will contain a link to the alert page. This page provides basic information about the issue. In this case, it is telling us that the latency on the front-end service is high. It also shows us the trend of latency over time. We can also see related alerts here. Here we see an alert for errors on the front-end service. Let's investigate it more. We can see that the error is high on the front end and it corresponds with the latency increase. The alert also provides context cards that contain insights that might help explain the issue. The first two cards here analyze log messages for anomalies. These cards are telling us that the error started happening after the alert and did not exist earlier. They're also telling us that the errors are primarily happening talking to cart service or getting product recommendations. A small percentage of logs also have errors talking to other services. Let's click on one of these observations to learn more. Looks like users are having issues interacting with the cart. Coming back to the alert, we see another card. This one surfaces anomalies by looking at the metrics data. Here we see a bunch of pod failures happening in the system. We see cart service again, which has a bunch of pods that are crashing. We already know that front-end errors are caused by the cart service. In addition, this anomaly is telling us that cart service in turn is having some issues. Let's investigate it more by going to Explorer. Here we can see that the pod crashes might be happening because of the CPU and memory pressure. We can provision extra resources to fix the CPU and memory, and hopefully that should resolve the problem, and our customers can get back to shopping on our website. As you can see from the demo, the alert response feature makes it very easy for you to troubleshoot issues quickly. It provides you anomalies not only at the application layer, but also on the infrastructure layer, and tries to correlate them together on a single page so that you are able to find the issues more quickly and more efficiently. With that, we'll open it up for Q&A.